Okay, so hello everyone. My name is Simit, and I am in second year Information Technology Department of IIEST Shipur. And today we'll be discussing about the standard template libraries and various data structures available in standard template library of C++. And in Python, we'll be discussing about those data structures in general, and then we'll show you how to implement those data structures in both of these languages. Okay, so let me first tell you about the general structure of today's session. So uh, I'll be telling you about these, okay, and then after me, uh, and I'll be discussing about these, and then I'll tell you about how to implement these in C++. Okay, and then Anushka will tell you about these, and she'll tell you about like uh, how to implement these in Python. She'll tell you about how to implement all of them in Python, but uh, the theoretical stuffs she'll be discussing about these, and I'll be discussing about these. Okay, I'll be telling you about implementing all of these in C++, and she'll tell you how to implement all of these in Python. Okay, so I guess we are good to start. Okay, I guess I am audible and my screen is visible. Can anyone confirm, please?
Yeah, you're audible and your screen is visible
Thank
as
you.
well.
Thank you, Anushka. Okay, so let's just start by like uh, uh, all of you must be familiar with arrays. Okay, so arrays are nothing but fixed size container. Okay, they contain elements of a specific data type. But a problem with them is like they are fixed size. Once you define an array of size, say three, three. Once you define an array of size 8, then the size of uh, the array will remain 8. Okay, you won't be able to increase it or vary the size according to your needs. Like what happens is when you create an array in the memory, a continuous block of memory is allocated to the array. For example, create like this. For example, this is your big pool of memory. Okay, and when you create an array, for example, of size 8, so uh, this size will be allocated to array. Suppose this is of size 8. Okay, and once it is allocated, you won't be able to increase the size. Okay, because by definition it should be continuous, but it can be guaranteed uh, during the execution of the program that this space or this block will remain for you. It cannot be guaranteed. Okay, so you cannot increase the size of the array. That's one reason. So how do we solve this? As a solution, we have something called a variable sized array. Array. Okay. Now this data structure is called vector in C++. Okay, and this is called list in Python. So I'll be talking about general theory regarding vector. Okay, okay. though the only difference is in terms of syntax, but the general theory remains same. So what happens in case of vector, when you create a vector of any specific type, for example, let's see, uh, if we create a vector, okay, of int, and we name is it as v, then what happens is, uh, let's suppose we have allocated some size, okay, the size is here 8. Now when we create a vector of size v, what happens is, in the memory, okay, a large continuous section will be allocated, okay. It won't be of size 8, but it would be something like very large. uh, it can be something like, uh, for example, 10,000 blocks. So although you have created a vector of size 8, but what happens is, excuse me, what happens is, these 10,000 blocks are created, and only 8 will be available to you for your uses, okay. Now these all are also created, but you won't be able to access or use this, okay. So now now you only need 8 blocks, okay. So 8 blocks will be available to you. Suppose this is, these total are 8, so these will be available to you, and these won't be available unless you increase the size. Now uh, now what now now for example, if you need to, if there are already some elements here, for example 0, 1, 2, 5, 9, and some, and this is the last block, and here suppose it is 10, okay. Now you want to push something in it. In array it was not possible to push something, because it was of constant size, but in vector it is possible. Now if you want to push something to it, now what will happen, for example, if you do something like v dot pushback. Pushback is a function in C++. Now if you want to push 14 to it, now what will happen? Now you already have these 1000 blocks with you. Now what your compiler will do is, it will take one extra block, okay, and it will just add 14 to it, okay. Now the size of the vector is 9. It has increased by 1. So this is what happens in vector. Now one problem that might occur is, suppose you have this is your all of the memory. For example, this is your RAM. Okay. Now here are like all the 10,000 blocks that you have created. Now what will happen if you fill all of them? Okay. One question might be like, uh, for example, I created a vector and then I filled all of them with some element. Then what might happen? And then you want to push something into it. For example, in all 10,000 elements, okay, you have something. And now the problem is that after this block, these blocks were allocated to vector at the time of creation. Now this block, this isn't guaranteed that this block will remain available, okay. This block will remain available, so it isn't guaranteed. So what will happen, if I want to push some 10,000 first element to it. Now what your compiler does internally is, now it will again allocate memory in the RAM to some new location, okay. Suppose this was your original location, okay. This was your original location, and for here you had 10,000 blocks, 10k blocks. Now it will allocate new memory of twice the initial size, okay. So 2 into 10K block will be allocated to it, and your compiler will and what will happen, like all the elements will be first copied. So all the initial elements that were here will be copied. So there were the 10,000 elements will be copied. Okay, and then the 10,000 first element will be pushed here. For example, till here it was 10K, then this 10,000 first element will be pushed here. So this is what happens in vector. Now one problem is like copying all of these will take some time. Okay, so vector uh, can be said it is a bit slow than array, but that is something called uh, amortized. So, okay, so uh, I would recommend to go and search more about how amortized time complexity is done. So we often say that vector doesn't guarantee O of 1, but it is like amortized O of 1. Okay, so we had talked about asymptotic time complexity. Now, I would recommend to just go and search about this. So I'll just show the code in C++, how to implement that. Okay, and various functions I'll show. For example, let's see. So for creating a vector, what you do is you just write a vector, then you specify the data type of the uh, elements that you want to contain in it. So for example, I want to create a vector of int, and then you write the name. For example, it is, let's suppose, v. Then you specify the size. This is optional. Okay, uh, if you create like this is also good. And if you specify the size, that won't also be a problem. So like for example, I want to create a vector of size n, and then you can specify the uh, initial value. For example, I want to initialize each of the blocks with some initial value that is 0. Okay, and then I can like simply iterate over it. I equals 0, then I is less than uh, v dot size. Now this function, okay, so this v dot size, what it does, it just returns the size of the vector, which is 10 currently. Okay, so it will return 10, and then I want to increase it. Okay, so you can just iterate over it like you do in array. So I'll just print every element of it. So you can do something like this, and then space. Okay, so it will just print 10 zeros because the initial value is 0. So let's see. Okay, yeah. So here there will be 10 zeros. Now, for example, you don't want to specify any size. So now the size is 0. Now you can insert it inside the uh, vector with something called pushback. So this is another function. I'll just ask you to take note of every function that I am telling you. So the first function I told you about was v dot size. It returns the size of the vector. Then I told you about pushback. So it pushes any element into it. So for example, I want to push 90 into it. Okay. Then I want to push uh, 13 into it, and then 15 into it. Okay, so let's see. It should be 19, 13, and 15. Okay, there it is, 19, 13, and 15. So uh, now another function can be uh, related to vector. Like there are multiple functions, but these two are most important one. You would be using these two the most. So I told you about these two. Uh, for example, you want to erase an element. Okay, I'll tell you how to erase after I talk about iterators. So this was all about vector. I told you about two ways to create vector. Uh, uh, okay, good. So if you have any doubt, please raise your hand and you can unmute yourself and you can ask. So I'll then go to next. Uh, that is iterators. Now, iterators are very important in C++. Iterators are nothing but, for example, you have a container. So iterator is an object, okay, which points to a particular element in your container. So iterator is an object which points to, for example, I created an iterator which is pointing towards here. It can point towards here. It can point towards like any of the block. Okay, so I'll just tell you about how to create an iterator. You can just use the auto, then I, then equals. Now v dot begin. So what begin function does is it returns an iterator pointing to the first element. Okay, so I is an iterator, and the I iterator is pointing towards the first element. Okay, so for suppose we have something more like we, then we have 80, we, then we have 60. Now this is pointing towards the first element. So now there is another function which is called uh, erase. Okay, so for example, I want to erase 15 from my vector. Okay, so 15 is something somewhere in the middle of the vector. Yeah, so I want to erase 15. So what I can do, I can just, okay, I shouldn't have deleted it. Okay, I renamed it IT, and then I want to delete it. So I can do something like erase and then IT plus. Now this is pointing towards the first element. So if I do IT plus 1, IT plus 1 will point towards second element. Uh, then IT plus 2 will point towards the third element, and so on. Okay, so you need to keep that in mind. And now, for example, I want to erase 15, so I'll just like I'll write IT plus 2, and then let's run it. Okay, so you can see here the output 15 has been erased from middle of it. So now if you want to find an iterator pointing at the last element, no, not the last, but uh, something after the last element. So you can use something like auto it end equals v dot end. Okay, so where does it point? So for example, if you have a vector size from here to here, now dot end function returns an iterator which will point after the last element. So this was your last element. So dot end will return an iterator pointing here. So you need to keep that in mind. So I hope iterators are also clear. So uh, now is another useful function called sort function. So if you want to sort the list, you can just pass the iterator, the first iterator and the last iterator. Not the last, but the iterator pointing after the last element. So you can do something like v dot begin and v dot. I'll just request you to keep note of every function that I'm telling you about. So it will sort the vector in ascending order. So so now I hope these are clear. So this was all about vector. Uh, I'll talk you. Uh, I'll tell you about now another STL based data structure that is called map. Okay. So maps are nothing but a container of key value pairs. Okay. So for every corresponding key you have a value associated with it. Okay. So for example, if you want to store uh, roll number of students with their name. So the key can be a roll number, and the values can be something like name. Okay, so so I'll just tell you about how to create maps in C++. So there are two types of maps: unordered maps and ordered maps. Now, in ordered maps, the the container that is your map is sorted uh, according to the of uh, order of the keys. Okay, order of keys. And in unordered map there isn't any specific order, so you need to keep that in mind. So for example, I want to create something like a simple map. Okay, in C++, creates a map, an ordered map. Okay, so in a simple map we'll create an ordered map. So uh, how do we create a map? We, we can use the map keyword, and then uh, for example, I want my key to be an integer, and then my value is also for example, value is a string. Okay, sorry. So and the name of the map is students. Okay. So now, as I told you, like the map keyword creates an ordered map. Means like if I now for every key, okay, I can assign some value to it. So for example, the roll number of the student is something like 40, and I want to I want to like specify a name corresponding to that roll number. So I can do something like A, and similarly, it is something like if it is something like 30, then I can do something like B, and B would be 4, C, and so on. So you can create a map like that with every key. These are your keys. You are assigning some value. So if I want to find the value corresponding to a key, so what I can do simply, I can just print. the students at 30. So it should be B because the value corresponding to 30 is B. So I can do something like this and this. So it is B. Okay. Now you need to keep that in mind is that in ordered map, how will all the elements be stored? So I first stored 30, 40, 30, and then 44. So initially, corresponding to 40, A was stored, then corresponding to 30, 30 is less than 40. Okay. So uh, it will come before 40. So corresponding to 30, B will be stored, and then 44 is greater than 40. So corresponding to 44, C will be stored. So it follows a specific order. That's why it is called ordered map. So the problem with ordered map is inserting any element takes a time log n. Okay. Accessing any element will take a constant time because you are just going at that key and you are fetching the value. But inserting any element is going to take log O of log n time. So if I add a new element, something like 88, that will be inserted at the last because 88 is greater than 44. So it will take a log n time. Log n is the size of the map. So here 3 is the size. So something like O log n is a time complexity. So another way to iterate over the map is you can do something like a way to like auto, then you can just write in this way. Okay. So so this is an also an iterator. Now it is pointing towards every container. So this is one container. Okay. This is one container. This is one container, and so on. Okay. So I am iterating over every container. Okay. Now I want to print uh, the keys associated with every container. So in every container, I shall use different colors. So like in every container, for example, this is one of the container. You have two objects. First is the key, and second is the value. Okay. So IT is pointing towards a specific container, and then if you want to get the key in this container, so you can do something like IT dot first. Okay. Then you can just let's see. See, although I created 40 first, then 30, then 44, but the order here is sorted. Okay. Why? Because I told you uh, uh, all the elements are stored in sorted order. So if I want to get the value, then I can just write it dot second. So the first is pointing towards the key, and the second is pointing towards the value. So see, okay. Okay, corresponding to 30 we have B, corresponding to 40 we have A, and 44 we have C. So I guess it is clear. Now, now there's something unordered map also in C++. So it guarantees. Now here insertion was taking O of log n time. Now in ordered maps, insertion is takes an average of mind my words. I'm not saying uh, it is not the worst case. It is an average Now insertion takes an average of O of 1. Okay. In worst case, it can go to O of n. That is even worse than this. O of log n. O of n is worse than O of log n. So in worst case, now in any case, uh, this ordered map will give you a guarantee of O of log n, but in unordered maps, okay, the problem is in worst case it can take O of n, which is even worse than this. So you need to keep that in mind. But in average case, this is O of 1 is far better than O of log n. So if I want to insert something, let's for creating an unordered map, I just need to write like this, unordered map, and everything else remains the same. Okay. Now here it isn't guaranteed that any specific order will be followed. So let's see, I have something like control B, and then I've created something like O of. Uh, okay. Now let's see. Everything else is same, but here you can see no specific order is being followed. Now, even the order of insertion is not being followed. For example, like I inserted 40 here uh, at the start, but the first element is 44 and C. So I hope it is clear. Like no order is being followed in unordered map, and it guarantees you, and I won't say guarantees, but the average time complexity of inserting anything in this is O of 1, which is better than an ordered map, but the worst time complexity can go like up to O of n. Okay, so this was all about map, I guess. Yeah, and then we have something like another data structure that is called set. So, so in set also there are two types of sets: unordered set and ordered set. Okay, so unordered set and ordered set. So now you must have guessed that ordered set means, now what is a set? A set is a collection of element of same type. Even like I mean like uh, a set of natural numbers. So it will be something like 1, 2, 3, 4, and can go up to infinity. So this is a set. Okay. Now, one thing to keep in mind is in set there can't be repetitions like this 1, 2, 2, 3, 3 is equivalent to or equal to 1, 2, 3. Okay. You must be knowing about this from your basic maths. So a similar thing happens in set in uh, C++ or Python. So if you try to insert any duplicate element, uh, the duplicates elements are not inserted. Okay, only one copy of a particular element will be inserted. Now sets are also ordered and unordered. In ordered set, the worst time complexity can be similar to map, that is O of log n. Okay, and in ordered unordered set, thus watch time complexity can be something like O of n. Okay, now let's see. Uh, let's see unordered set. Uh, So how to create a uh, let's first see unordered set. Okay. So for unordered set, you can do something like similar like what I did in map unordered set, and then I want to create a set of, for example, integers. Okay, I can do something like s. If I want to insert anything inside the set, then I can just call the function s dot insert one. Okay, and two. So I inserted one two times, and then two, two, three, three, four. Okay, that's fine. Now I'll do something similar. I want to iterate over every element of the set. Okay, so what I'll do, I'll just do something similar I did in maps. So S, and then I'll just see out I. Now here you don't need to like do I dot first and I dot second because here only one element is there. So you can do something like this. Let's see. Okay, sorry. Let's see. So this was unordered set. Here you can see uh, there is no specific order. You might say that this is in ascending or sorry, descending order, but that's not quite correct. Like if I insert here 0, then let's see what happens. Okay, so no specific order is being followed. Okay, but if I do something like only set, then it will be an ordered set. Okay, so this is an ordered set. Let's see. Right. So we have 0, 1, 2, 3, 4 here. This means this is following a particular order, that is a ascending order. Okay. So this was all about set. So the main point is you cannot have duplicate elements here. Okay. And yeah, I think it took enough time. So there are many more functions like uh, s dot size will return you size of the set, and s dot find will return whether an element is present. So let me write. Okay, a little bit. So s dot size will return the size of the set, and s dot find will return whether a particular element is present or not. Uh, I'll just ask you to go through each of the functions, sorry, each of the uh, data structures that I told you, like the functions of each of the data structure. I'll list here, like I told you about vector, I told you about maps. In maps, we had something like unordered map, ordered maps. Then we discussed sets. We had unordered set, ordered set. Okay. So I'll just ask you to go through the functions of each of the data structures that I told you about. So I'll now hand over to Anushka.
Also, Simit, there are some questions in the chat box. You can
Okay,
check
okay.
them on maybe.
Yeah. Sure. There are many questions. Okay. Everything about vector done. Yeah, like every basic thing I have covered. Like you need pushback. You need. I told you about like pushback. Okay. Then I told you about how to find the beginning and the end of iterators. Then we had size. Then we had erase. Now, similar to erase, we have something like insert. Okay, I missed this, but I'll just ask you to do something on your own too. Like I told you about, there will be many functions in vector too. Like it's not possible to go through each and every of them. So these are something, some major thing, and something like you have something like pop back. Okay, so pop back just removes the last element. Okay, of the vector. Okay, why auto I and not only I? See, auto is a keyword which assigns data type depending upon the value that we are giving it. Like for creating an iterator, that data type is something like iterator. Okay, so I just use auto because writing iterator in CP is like it is a long keyword. Okay, so I generally use auto, so it is best way I can find. uh, I auto I, and not just, not only I. Like how will only I do? Like you need auto. Iterator is an object. Okay, I told you that iterator is an object. So for each object you need to specify its data type, and what auto does is like it automatically uh, assigns the data type. Various positive range based loops and auto keyword. No, it's not necessary. Okay, you can use iterator data type. Okay, for creating an iterator. Auto keyword. Yeah, it's not necessary. For example, if I wanted to create something like auto I equals s dot begin. Okay. Now I can do something like I is less than s dot end. Okay, and then I can do something like I plus plus. This should also do. Let's see. Okay, I have something like I'm missing something. Okay, I guess. Okay, sorry. This I'll have to create vector for it. Okay, no issue. So I have less time, but okay, I'll just create vector, and you can like do something like this. You can assign an initial value in iterator, and then you can have a condition, and then you can simply like uh, uh, increment each time in the loop. So you don't need to like just use range based loops. to erase a value by index, and also how to erase if only the value. Okay. So by index, you just need to pass like uh, for example, v is your vector, then you just need to do something like erase and v dot begin plus the index. Like if it is zeroth index, then it will remove the first element. If it is first index, then it will remove the first element, and so on. There are many questions. Is there any alternative of auto? Can we use class name here? Yeah, you can use iterator. I told you about. I generally use auto because writing it is short. Do we have to remember these? Yeah, you need to remember these all, but you'll get used to it as you use it. Okay, thank you for your concern, but yeah, I'm okay. Yeah, I have a cough, but thank you. Okay, thanks. So now, Anushka, you can take over.
Okay, so hello everyone. I'm Manishka from the Department of Information Technology second year, IIST Shipur. And I'll be taking your session on stacks, queues, and priority queues. So let me just share my screen first. Mm, So is my screen visible? And you can write in the chat box maybe. Okay, thanks. So, just to remind you the flow of the session, I'll take your session on stacks, queues, and priority queues, and after that, Seemit will explain how to implement those in C++, and after that, I'll explain how to implement all these data structures that we learned today in Python. Okay, so just a second. So let's talk about stack first. So, what do you mean by stack? Stack means you can think of it as something like a stack of plates. So, if you have a stack of plates, suppose you have a stack of plates. So, you have this stack of plates. Can you pull out this stack or this plate from the bottom? I don't think so. If you try to take this out of this stack, all these things will fall, or it's not possible. So, what you are going to do, you are going to only take the plate that is on the top of the stack, right? So that is the only thing that you can do here. And if you want to keep a stack, if you want to keep a plate on top of it, you can only place it on top. You cannot place it in the middle of this stack, right? So stack means something where you can only do this operation on the top. So suppose you have an array, or let me first say that this thing is called LIFO. LIFO means last in, first out. So if you place a plate on top of this stack first, the first plate that you are going to take out from this stack is going to be this one, right? Not this one. So that was the first plate that you put, and you are going to take that out at the last. So after you have taken out all these plates here, you can take out this plate here, right? You cannot take the last plate out without taking out all these plates. So that is last in, first out, or you can also call it first in, last out. Last in, so the one that goes last comes out the first, and the one that goes first comes out the last. So in case of an array, uh, So suppose this is our stack. Here we are placing the numbers, like this end is blocked. You cannot place anything here. You cannot place anything in the middle. You can only place on top of this thing one by one. So suppose you can put one number here, maybe 5. Then you are putting another number here, maybe 6. Then again another number, maybe 12. Then another number, maybe 20. So when you are taking out, you can take out 20 first. You cannot take out 5 first. Then you'll have, this is gone. So after that, 12 is exposed. So you can take that out first. So the only the top element is the one that you can take out. So in an array, suppose you are using something like C language. In that case, you'll not have inbuilt functions or anything. So for that, you'll need to maintain a top variable that will give you the location of where your top of the stack is. So before I have anything in my array, it's empty. My stack is empty. So this end is closed. I cannot put anything here, but I can put things here on the right side of the array. So I can fill things here, or I can take things out from here, nothing from the middle. So in that case, your top variable will be -1, because your top variable, your top element is the one that you can take out. So now here you do not have any element here, so your top is -1, so you cannot take out any element from here. Once you want to place an element, suppose 5, so your top becomes this one, so your 0th index becomes your top. Next time you place 6, so your top becomes your index 1. Next time you place 12, your top becomes your 2. So 20, so your top becomes 3, index 3. So once you want to pop the thing, what you are going to do, you are going to remove this item at the top variable. So top was 3, so you are going to remove 20, so top becomes 2 now. So that is how stack works. So in case of languages like C++ and Python, you'll have functions. I'll show you at the end of the session. uh, So that is about stack, and there are the few functions that you have to know about a stack. So first you have the push function. Push. You have pop, and the syntax will vary according to the language that you're using. And then you have is empty. The functions that you need to know about in order to use a stack data structure. Is full, and peak. So let me explain what these functions are doing. So push means push something in my stack. So here pushing means I am placing a plate on top of my stack of plates. So here in the this one 20, after 20 I am placing something, so 30. So I am pushing something to my stack, pushing something to my stack, pushing something to my stack. So that is push. Pop means I am taking out the first plate, the topmost plate from my stack. That is pop. So here 30 was the last element that I pushed. So I can only pop this one out. So I'm popping this one out. After that, I am popping 20 out. After that, I'm popping 12 out, then 6. So pop means to remove the topmost element from my stack. Is empty means whether my stack is empty or not. So you'll have to see if the top variable is -1, that means you have nothing. So your top is before 0, so you have nothing in the array. So in that case your will be stack will be empty. For full, if you have a maximum length of the array or the stack that you are using, so if it's filled, length of the stack is equal to the maximum length, then in that case it will be full. And peak means you are trying to see the value of the top element without removing it. So when I said pop, I was removing the topmost plate that was there. So when I said that pop, so I had 5 here and I had 6 here and I had 12 here. When I said pop, I was removing this 12. I was removing this 12 and I was getting 12. But in case of peak, we are just going to see the value without removing. So I'll just say if I do peek on this stack, I'll get 12. I'll not remove it. The stack remains same. So that is about stack. And queue is like a queue, like a people standing in a queue. So the one who comes first gets to go first, right? So queue data structure is first in, first out. So that means suppose you have a queue like this, and this was your first element. So your 5 was your first element, 6, 12, 20. So 5 came first. So 5 will go out first as well. 5 came first, so 5 will go out first. So your people will be coming in from the back, right? People will be coming in from the back, and because 5 was the first one who entered the queue, 5 will leave first. So after that 6 can leave, then after that 12 can leave. So in that way, so the functions that we use here are enqueue. Enqueue means I am placing something at the end of the queue. So that is enqueue. So after 5, 6, 12, 20, I was placing maybe 32. So when I am putting this at the end of my queue, I am calling it enqueue. That is enqueue. Dequeue means 5 can leave now. I am removing 5. The first element of my queue can be removed. So when I am removing 5, so my queue now becomes this. So this will be my dequeue operation. So you can think of this as the push function in stack and the pop function in stack. Similarly, it also has is empty, is full, or peak. You can understand that. For implementing, what you are doing is, for implementing this queue, you have a head variable and a tail variable. Okay. So your head is suppose 0 at the beginning and your tail is 0 at the beginning. So you can see that head is the one where my queue starts, right? Head is the one where my queue starts, and tail is the end where my queue ends. So I can always remove the first element of the queue. That is, the first person who lined up first can get to go first. So this is my head, and I can only remove my head. So when I am dequeuing, I can only remove my head. And what is the function of this tail? By the tail, I know where the line ends. So the next person who wants to join the queue has to join at the end. So the person will join after the tail, right? So this is the function of the head and the tail. So at first you'll have head equals 0, tail equals 0, and then once you put some number in it, like enqueue a number, so you are enqueuing 5, so your tail becomes equals 1 because head is still 0, the index that you can remove. So after that you put 6, then you tail becomes your 2, then 12, then your tail becomes 3, then you put 20, so your tail becomes 4. And when you are removing, uh, so when you are removing, you can remove your head, that is 0th index, so you can remove 5. Now your head becomes 1. This becomes your head. So like that you can enqueue and dequeue in a queue. And also there's a thing called circular queue. As you can see that a lot of space is being wasted if you are removing this. Like suppose you are enqueuing something here. So once you are dequeuing here, so this will get removed. After that, this will get removed, and you cannot add anything at the end because that was your max limit in the queue. So this space is wasted, right? There are 3 more spaces left in your queue, but you cannot enter any more people in the queue. So you do not have any more space here. So for that thing, what we do is use a circular queue. So circular queue means the tail is connected to the head like this. I mean, the tail is not the tail is connected to the head. Sorry. So it's in a circular manner. So suppose your queue does not have any space left here, so it's going to start filling from here. So suppose your queue does not have any space here, so it will start filling from here. Then it will go here, then it will go here, wherever it finds empty, one after another. So if I have to show a circular queue, it will be something like, think of this like this. So this was my 0th index, 1, 2, 3, 4, 5. So my max limit is 5. So if I am entering something here, so my head will be here and my tail will be here. So I entered 5 maybe here, then I entered 6, so my tail comes here. So then I entered 12, my tail comes here. So after that 20, so my tail is here now. 32, so my tail is here. And I have 17, so my tail is here. Now suppose you are dequeuing from here, so your head comes here, your tail is here, and your head comes here. So this space is empty now. So the next time you want to enqueue something, you can place at the 0th index. After 5, you can place something at the 0th index. So that is how a circular queue works. And there's something called a doubly-ended queue, double-ended queue or DQ, not to be confused with a DQ here. So this one was the operation, the pop kind of operation that we were performing. And there's something called double-ended queue. And this is also called DQ. In this, you can insert and delete. You can insert and remove from both the sides of the. So you can insert from here. You can insert from here as well in both the direction, and you can pop from here and you can pop from here as well. So that is a DQ. So what we did was stack. So stack, in the case of stack was LIFO or FILO, whatever you can say, that is last in first out. So you can insert from here and remove from here, only one way, only from one side. In case of queue, you can insert from the back and you can remove from the front. And in case of DQ, you can do it both ways. So was it clear till here? Anyone has any questions? You can write in the chat box. Okay. So just a second. Okay, so let's talk about priority queues now. So priority means something that we are preferring first, right? Priority. Let's talk about priority queues. So priority queues means whichever element in my in my queue has the highest priority, I'm going to give them the preference and let them go first. So here our first in first out order is not maintained. Whoever has the highest priority, we are letting them go first in the queue. So suppose I have these things like, suppose this was my head and this was my tail, if you are thinking about a queue. So suppose I have A, and suppose I have B, and I have C, and I have D. And if it was a normal queue, what would have done, A would have come out of the queue first, right? After that, B would have come out. After that, C would have come out, and after that, D would have come out the last, because it entered the queue at the end, at the last. But because it is a priority queue, we have some priority values, like which elements am I going to prefer first. Like I do not like A, so I do not want to let A go first. So A has some kind of priority. Let's represent the priority values by P. So A has the value 1, B has the value suppose 8, C has the value 4. So these are some kind of value, like priority value, the way you are preferring the elements here, and P equals to 10. So we are going to take the highest priority one out first. So even though here, even though D entered the queue at last, but D has a much higher priority than the other elements. It has the highest priority. So while we are dequeuing, while we are taking them out of the queue, D will get to come out first. After that, so D is gone now. So after that, B has the highest priority. So B can come out now. After that, C has the highest priority, so C can come out now, and A comes out last. So even though it entered first, there's no guarantee that it's going to come out the first, because FIFO order is not maintained here. What we are doing is checking for the highest priority and letting them go first. So what is heap? So heap is actually a way we are implementing priority queue. They're not exactly the same. So heap is just the way we are implementing priority queues. So heap. So for heap, you need to know about trees. I'll say that you do not need to know about trees. Heaps are stored in trees, something like binary trees. So even if you do not know what trees are, that's fine, because when I learned heaps, I did not know about trees. So I'll just explain you in short and easily. So the first concept about heap is, first let's just see what heaps do, and not go in about the details of how they are doing it. Let's just know what they are doing. So if you have a heap, suppose this is your heap, suppose this thing is your heap, you don't need to know what they are doing now. And if you pop from here, what's going to come out? The highest priority element. The highest priority element is going to come out if you pop from here. And if you push something there, it doesn't matter, because it's going to go at the end or something like that. You are not concerned about that, because how it's inside the heap, it is of no concern to you. When you are popping, you need to see which one comes out first, right? So when you are popping in a heap, the highest priority element is going to come out first. So there are two types of heap. One is min heap and max heap. Min heap and max heap. So in min heap, we are preferring the smaller elements first. So suppose we have something like array like 3, 2, 1, 5, 7. So we are preferring the smallest element first. So when we are popping, first we will get 1. After that we will get 2. After that we will get 3. So every time we'll get the smallest element first out of this. For max heap, it's just the opposite. The largest element will pop out first. So let's talk about the implementation. I think if you are given the functions of the heap pop and heap push functions, I think you'll be able to implement them if you know these things. But just in case you're curious how the things are working, I'll explain them. So heaps are represented, usually represented in arrays, but think of them as a tree. So here they are complete binary trees. Complete binary trees mean, let me show you. Binary trees means each node has 2 children. Even if you don't know what trees are, you don't need to be worried. You can just see this and try to understand. So complete binary trees means we are filling them level by level. So first this one, second this one, next this one. After that we will have here, we will fill here, then we will fill here, then we will fill here. We cannot directly fill here. Okay, so if this is the tree, then that is not a complete binary tree. So you cannot call that a heap. So we have to fill level by level. So after that, this one, then this one, then this one, and then this one. And let's say there are index numbers. If we are thinking of this in an array, suppose these are my index numbers 0, 1, 2, so in the heap it will be something like, since it's 1 by 1, so 0, 1, then 2, then 3, then 4, then 5, then 6, then 7, then so on. Okay. So for your first element, so for this element, these two are my children. This and this are my children. For this one, for this element, this one and this one are my children. For this element, my parent is the one at the top. So for 3, my parent is 1. For 3, the children are 7 and 8. So if you want to know how to know this in an array, for your ith element, for your ith index, your parent element is going to be equal to the parent index of your parent is going to be floor of I minus 1 by 2. So that is going to be your parent. So for suppose for 4, what is going to be my parent? 4 minus 1 is 3, 3 by 2, 1.5. So floor of that is 1. So for 4 parent is 1. For 4, parent is 1. For children, there are 2 children. One is the left child and a right child. So for left child, the index is 2 into I plus 1. And for the right child, it's 2 into I plus 2. So you can see here for maybe for 2, its left child is going to be 2 into 2, that is 4 plus 1, 5. 4 plus 1, 5, you can see. And the right child is going to be 4 plus 2, that is 6, and you can see 6 here, right? So that's how we are representing this tree in an array. Now you know how to represent this tree in an array in case of a heap. So let's see. Also, what will be the height of this heap? The height of the heap will be log of n because it's a complete binary tree. For a complete binary tree, the height is log of n. For n number of nodes, the height will be log of n, here to here. You can see since it's it's having 2 children, so for that case it will be log n base 2 height. Now we want to know how to insert an element in this array. We want to know how to insert an element in this heap. Okay, so one thing I did not say, how the ordering of the elements in a heap are. So since it's a heap priority queue, so we are maintaining the priority at each level. So suppose you have something like 2, you can have something like 2, and you can have their children, as we are doing for min heap. So our most priority, we are giving it to the smallest element, our preference priority. In heap, we are doing it for in heap. So for 2, we can have element 9 and 7. It doesn't matter in which order. You can have 7 or 7 and 9, does not matter, but they must be greater than 2 because 2 is the 2 has the highest priority here, so 2 gets to sit at the top. After 9, you can have something greater than 9. You cannot have something smaller than 9. So you can have 10 here, and you can have suppose 55 here. So for 10 and 55, 9 must be the smallest out of these three because 9 is the parent of these. So the parents are always having the highest priority, higher priority than its children. For 7, you can have something 8. You can have 8 even though 9 is here. It doesn't matter. It's only concerned about its parent. So it's greater than its parent. That's okay. So the minimum one is the parent. Higher priority. So it's the parent. And then you can have something like 3. It doesn't matter as long as it's no. You cannot have 3 here. Can you have 3 here? No, because 7 is greater. So 3 should have been the parent, right? So that's not how it works in a heap. The higher priority one should be the parent. Now suppose you are trying to insert something in this. Let me draw a new heap. Suppose you have this one, 2, then 9, then 7, and then you have 10, 55, and 8. And now suppose you are trying to insert a new element here in this heap. So one thing you can see that the topmost element is my highest priority. So whenever we have to pop, I can just get this element. So there is not going to be any problem. Now, I'll show you. Pop also has a mechanism so that the heap is maintained. So here, suppose you want to insert an element, let's say 3, since I was checking for 3 before. Let's say we want to insert an element 3. So let's just add it at the end of the array. So my array was previously something like 2, comma 9, comma 7, comma 10, comma 55, comma 8. And now I am inserting it at the end first, and then we are going to adjust it in the heap. So I have inserted 3 here, but that's not the right place because 7 is greater. It should not be greater because its children is child is 3. So the smallest one should be the parent here. So what I'm going to do is I'm going to swap. I'm going to swap these. So my parent now is 3 and this one is 7. Now you can see the ordering is correct. You can see that the ordering is correct. From 2, 9 and 3 are both greater than 2, so no problem. 10 and 55 are both greater than 9, so there's no problem. Then 8 and 7 are both greater than 3, so there should not be any problem. This is a heap. Now suppose you want to add another element. Suppose you want to add another element 1. So it'll be inserted here. So here we had swapped. So this one is now 7 and this one is now my 3. And at the end, I am trying to insert another element that is 1. Now, definitely 1, this is not the correct place of 1. So what we are going to see, what we are going to do is check with its parent. So 10 is definitely greater. So this becomes my 1 and this becomes my 10. So I swapped them. Now I'm checking 1 and 9 with its parent. So definitely 1 is smaller than 9. So it cannot be its child. So this one becomes my 9 and this one becomes my 1. Now I'm again checking it with my parent. So 2 is greater. So 2 cannot be there. 1 must be the highest priority here. And so 2 becomes here. So my heap now becomes something like 1, 2, 3, 9, 55, 8, 7, and then we have 10. And what was my time complexity for inserting here? So for time complexity, you can see that for a tree with n nodes, suppose there are n nodes, it will just take as many number of operations as the height of the tree. So the height was my log n log n. So my time complexity is O of log n for insertion in a heap. So that's how we are inserting in a heap. Could you understand that? Okay, so you do not want to know this. All right. I see. Okay, so I was going to explain the deletion and all. Uh, so I'll not explain deletion then. I'll just show you how it's working then in Python. So Simit is going to show you first in the C++, and then I'll show you in Python. And for questions, I did prepare a question, but I think it might be a little bit difficult. Uh, okay. So I'll show you an implementation of Heap, but before that I'll show you how to do those things in Python and all. But before that, I think Simit can explain how to implement stack queues and queues in C++. And anyone has any questions? Okay, I think Simit, you can show them in C++ first, and then I can show.
Okay, sure. Okay. So I'll first like I want to correct a few things. I just told that okay, the insertion in an unordered set takes a time of O of n. Sorry, that is O of one insertion. And if you are searching for any element in an unordered set, you can search it using a find function. Just okay, and that will take an order of n time. And searching, this is insertion, and this is searching. And in ordered set, the searching will take O of log n. Okay. Similarly, in map, we have maps here. I told you that this is the insertion time in an ordered map, and the same time is uh, the same is for searching. Okay, so searching is also of O of log n in ordered map, and insertion in unordered map is O of 1 insertion, and searching for a particular key is also O of 1 average case. So these were a few small correction. And okay, I'll just tell so for stack it is simple. You just need to write stack, and you need to just specify the data type. And for example, P is the S is the name of the stack. You just if you want to push something into stack, you just write S dot push and something like 4. And we have same thing like 5. And if you want to like access the top element, then it can be like S dot top. Okay. This will give you the top element of the stack. So here the top element first 4 is pushed, then 5 is pushed. So the top element will be something like you need to some int s equals. So this will give you the top element that is 5. Okay. And if you want to pop something out of it, like if you want to remove the top element, then you just need to write s dot uh, pop. So it will remove the first element at the top. And if you want to get know the size of the current stack that you have, you just need to write s because this will return the size. Okay. Now, if you want to know whether your stack is empty or not, you just need to write s dot empty. Okay. So it will return, if it is empty, it will return something non-zero or true. Or if it is not empty, then it will return false. Okay. So these are only the major functions for the stack. And for q q you have something similar. If you want to create the queue of int, then you can create like this. If you want to push something in the queue, you can just use push. So 4 will be pushed, then 5 will be pushed. Now you have 4 at the front. Okay. And if you want to access the front element, so you can just write s dot front. Okay. If you want to remove the first element, the topmost element, you can just write, sorry, there should be q. Okay. Q. And if you want to remove the top element, you can just write q dot pop. And similarly, s will give you size. Sorry, I used the same variable name. I shouldn't have used. Okay. And this will return whether your queue is empty or not. So something like bool is empty equals something like this. So this is for the queue. Hope it is clear. Now, if you want to create priority queue or heap, so priority queue and heap are similar things. So you can just write priority queue. So this will create a priority queue sorted so 5 is higher priority, so it will be on the top. 4 will be in the at the bottom. So rest all the functions are same. Okay, everything is the same. So this will just create a priority queue. So based on the priority elements, the order of the elements will be decided. Uh, then we had yeah, that's all. So I talked to you about this. In STL you don't have circular queue, you have something called dq. For dq you can something write something like this dq, and then all the uh, operations will be same. Okay. So for in C++, you can implement everything like this. Okay. You have any doubt? When to use front and when to use top? See, top is for stack. Okay. Keep in mind, top is for stack, and front is for queue. Okay. The rest push is same for both stack and queue. Dot size, dot empty is same for both. And we had pop is same for both. Okay. So that's all from my side. Anushka can show.
Yeah. So are there any Python coders here? Otherwise, there will be no use of explaining it in Python, I guess. So are you all interested in knowing the ways how to implement these things in Python? Well, is my screen visible? Okay. So I guess my screen is visible. Okay, yeah. So first thing, yeah, I'm going to explain in Python 3. So the first thing is that we use, I think this screen is also, I mean, the font size is good enough for this one. So in Python, we do not have a fixed size array. You can, the array size is variable. So everything is like vector in Python. So I guess those of you who use Python, you already know that for arrays we have these functions. I think you already know that for an array, or we call it list. We call them list here. So we have list. For list, let's just note down the functions now. For we have append function, we have pop function. So these things will also be used for stack, because stack is basically an array and we are just using one end of the array and nothing, you are not changing anything in the middle. So of course, I think you already know. I'll just show once and then focus more on the other data structures. So suppose you have a list named X, and you have some elements like anything, and you want to append at the end. So what append function does is append the element that you are trying to add at the end of this list. So if you append 23, then your X becomes this. So 23 is appended at the end. And if you do pop, so first comes out 23, and then after that, if you do pop, 5 comes out. After that, if you do pop, so one by one you can pop these things out of the array. So you can see that the function of pop and append are as the same as the push and pop function of stack. So by implementing these functions, you are already implementing stack in using this list. And what else is there? Also, I think you know that in case of Python, if you are doing x, so now my x is 976. So if I do x minus 1 in Python, in C++ it's not there. In x minus 1 for Python, it's going to give me the last element. So you can use this as the peak function of your stack. So in case of stack, I said that peak is the one where you are not popping this. So your x is still same. So in case you can see that after I pop 2350, those things are removed. In case of this, you are only peaking. So you are not removing the last element. And there's also the sort function. I think anyone who uses Python knows how to use that sort function. So what sort function, you may get confused between sort and sorted. There are two functions in for a list in Python. So there's sort and there's sorted. So what sort does not return anything, and sorts the array or sorts the list in place. So now if you after using sort function, if you print sort, it's going to be sorted. If you print x, it's going to be sorted. But sorted functions, in case of sorted function, it creates a new list and then sorts it. So suppose you have x again. Let me just write this thing again. So if you do sorted, suppose you are doing sorted x, so your y will be the sorted version of x. You can see that it's sorted, but your x will remain same. So that's the difference between sort and sorted. Similarly, in Python, you have reverse, dot reverse, and dot reversed. So you have something like x dot reverse for reversing the list, and you have something like reversed for if you want a separate copy of it. So I think these things were known to you already, because if you are using in Python, these things are pretty common. For Q, if you are okay, so let me show you Q first, and then I'll move on to the things like maps and all. So for Q, what you need to do is, in this array, suppose you have this array X, you have X, and you want to append something. So in Q, I said the head is the one that gets removed during the head is the one that gets removed, and the tail you add at the end. So in this case, append function is enough to add anything at the end of it. But for removing this, you cannot. You can do dot pop 0. So if you do x dot pop 0, that is going to give you 9 out of this array. So 9 is gone now. So you are removing 9 out of this queue. But this pop and bracket within brackets, if you are passing the index, this function is going to take O of n time complexity, O of n. But in case of a queue, that is not how queue works. In case of queue, removing and inserting both should take O of 1, because like I said, in C and all, you are maintaining a head variable and uh, head marker, and you are just increasing the head pointer here, so you can get this one here. So in this case, what we are going to use, we are going to use dq. So it's the same dq that I showed, that's the doubly ended queue. Since it has both the functionalities of stack and queue, you can use it to implement queue in Python. So for that, I'll need to import this from collections. I'll need to import dq. So now if you have this as, let's make this dq first. So now our x is at dq, so it's a dq. Now if you want to pop the first element, what you are going to do is, you are going to pop from the left. So dq has all these functions. So dq, my dq data structure has these functions. One is append, so it gets appended at the right end of the list. Then we have append left. Then we have pop, and then we have pop left for dq. So if you're trying to implement a queue, we just need append and we need pop left, because we want to pop the left element. So you can see here, x dot pop left is going to give me 7. So you got 7. And x dot append, let's say 2, is going to give me 2 at the end of the list. So that's how you are going to implement stacks and queues. And then I think you already know, in Python there's one more data structure, that's a tuple. So a tuple, what's the difference between a tuple and a list? A list is mutable, so you are adding and removing, inserting and removing things from the list. So in case of dq as well, so you are inserting and removing things. But in case of tuple is immutable, so it's unchangeable and it's an ordered, it's in an ordered way. So tuples, how do you represent tuples? So let's say t equals 4 comma 5 comma 6. So within round brackets, that's your tuple. So if you are trying to change something, like you can print it, but you cannot change it. So that's going to give you an error. You cannot change it in Python. And what else we learned? Okay, so let's go for set first. So for set, I think you already know how to do that. Let's say x equals, so that's an empty set. We cannot do x equals this one, because this represents a dictionary. Dictionary is maps in C++. The one we are calling maps, we are calling it dictionary in Python. So if x is a set, sets, in case of set, you can add by this function. So x dot add, you can add as many numbers as you want. So you have 8 and 9 in your set. Let me add a few more elements. So now this is my set. And now suppose I want to remove an element. So there are two functions. One is dot remove and dot discard. So I think you should take a note of these functions, because when you need them, you might just forget them. So x dot remove is going to work only if the element exists inside your set. So if you are doing x dot remove at 8, then it's fine, there's no problem, 8 is gone. But if you are trying to remove something that's not in the list, suppose 11, then it's going to throw you an error. So in that case, you can use a discard function here. So if it's there, it's going to discard it. If it's not there, it's not going to bother sending you an error. So you can see that 9 is removed, but if you are doing it for 11, it's not going to throw you an error. So there's no change, but it's also not showing you an error. So that's for set. And what else is there? Okay, so in set you can only store immutable things. So in store, if you are storing something like strings are also immutable in Python. So you can add something like hello here in this. So you can see that hello is there. So you can see one more thing, that sets in Python are unordered. So you entered hello at the end, but sets are unordered in Python. And if you are doing something like you're trying to add a list, because like I said, lists are mutable, you can change, you can append, you can remove things from there. You cannot add a list inside this set, unhashable. You cannot add a mutable thing inside the set. However, I said tuples are immutable, so you could have done this 8 comma 9, which is a tuple, should go. So there's no problem inserting this. You can see that, right? So that was for set. Now for dictionaries, you have the dict. So let's have a dictionary d equals dict. Oh, okay, so why am I doing this? So this one is an empty dictionary. So you can, how are you going to add an element? You can just write something like this. D of 9 is hello. D of 8 is hi. That's how you're inserting. You can also do it like this, if I'm not wrong, update 5. So this thing is going to do you the same thing, give you the same thing. Does it not work this way? Okay, so you'll generally not need this update function anyway. This one works fine, just fine. And if you are trying to access an element that does not exist already, so suppose you're trying to access 5 from here, your D is something like this now, and you're trying to access something from there. Suppose you're trying to access 5. In that case, it's going to throw you an error. Now, if you want to set a default value to it, suppose you want to find the value of 5, but if it is already not there, what you are trying to do is set a default value. So there's this function called set default. So if you are trying to find 5, if it is not there, then it's going to return you maybe something. It's going to return you something. So 5 is not 5 was not there in my keys in D, so it's returning you this one, whatever I set as the default value. But in case it was already present, so suppose for 9 it's already present, for that it is going to give you the original value. If it is not there, only then it is going to give you the default value. So that's set default. And what else are there in dictionaries? So in Python, dictionaries are also unordered. So if the standard dict that you are using, this one is unordered. So if you want to use an ordered dictionary in Python, you will need to import this from collections, import ordered dict. You will need this, and suppose you want another dictionary, and you can just do it this way. This will be your ordered dict. Now inside that you can just add your values like normally how you do. This just works as the normal dictionary, but You just have to import ordered dict from collections for that. There's also default dict. So for default dict, like I said, here you had to set default for if you do not want to throw an error for finding something that is not already there present in the list. So for that, you use something called default dict. So for that also, you'll need to import from collections, import default dict, and in that case, when you are declaring the variable, suppose it says this is my dict2, and suppose I want everything to have a default value of 0. In that case, I'll just write int. So my default values will be 0. So if I am accessing something that's not already present in the list, since I just declared it, there's nothing inside it now. So if I'm trying to pass in maybe a, so it's going to give me 0. So there's not going to be any kind of error. So if you want it to have a list as a default value, so an empty list, in that case you can just do this. So dict2 of maybe anything is going to give me an empty list. Suppose you want a custom value, suppose you want 7 here. So for that you cannot use int. For that you'll need to write something like lambda 7. You'll need to write lambda 7. So if I do something like anything, I can just, it's going to give me the default value of 7. So these were how you use dictionary. So this is also unordered. Default dict is also unordered. And there's also d dot keys. So this d was my this one that I already declared. That is the normal dictionary. So if I do d dot keys, you get all the keys here. If you do d dot values, you can take note of the functions if you do not already know. Okay, so d dot keys or d dot values. Now for priority queues, like I said, you do not need to know the theory or much. You just need to know how it works for implementing them in questions and solving questions. So for that too, you need to import heap. You need to import heap queue. So suppose you have the example that I gave you first, like suppose you have this heap variable that was your array at the beginning. Suppose you have some elements like 7, 9, 2, 10, 55, 8. Suppose you have these elements, and now you want to make a heap out of this. You want to make a heap out of this. All you need to do is heap queue dot heapify. So it will just make a heap out of this, because that's not a heap, right? After 7, so 7 is the parent. The children cannot be 9 and 2 because in Python it's min heap. So when you're importing heap queue, you're doing these functions, calling these functions. It's working as min heap in Python. So here min heap means 2 should be the parent here. 7 cannot be the parent of 2. That's not possible. So we want to make a heap out of this. So heap dot heapify, and my variable is heap. So now if you check your array, it's in a heap. 2, the children are 9 and 7, that's okay. For 9, the children are 10 and 55, that's okay, greater than 9. For 7, it's 8, there's no problem here. If you want to push something, so you'll do heap queue dot heap push. So where are you pushing it? In the heap. That is my heap variable, that list. And what are you trying to push? I was trying to push 3. So now 3 is there. You can see 3 is inserted wherever it should be. In the same way, if you are doing 1, so your 1 will be inserted. And suppose you want to pop, it's as simple as that. Heap queue dot heap pop. that's going to give you 1. Now your heap looks different. Like I did not show you the deletion operation, but like I said, you do not need to know what is happening here. There are some changes in the heap so that the order is maintained, but what you are concerned about is that the smallest element, you got it, right? So if you pop a few more times, you'll see that 2 is the next. You can see that after 2 there should be 9, but no, the heap has changed inside. So now 3 is your first element. So when you pop it, 3 is going to come out first. So that was all about the data structures that we learned today. Uh, Dictionary initialized by x equals set. What do you mean by this? Dictionary initialized by x equals set? Okay, yeah. I kind of forgot this. D dot update key value. Yes, I kind of do not use that. Does it give last element? Yes, in case of a list, it gives the last element. So if you have a list, so this one is also a list. We are just performing this heap operations on it, but it's actually represented by using a array or a list. So if you are doing -1, it's going to give you the last element, but there's no use of finding the last element here. So after popping, it was something like this. So there's no use of popping out the last element here, right? Or finding the last element here in a heap. So in a heap, you are only concerned about the first element because that is your highest priority element. You do not know what is happening inside the queue. You only want to know the person who has the highest priority. You want to only let them go.
Actually, he had asked regarding dictionary, x of -1.
So dictionary, I don't think you can do that. You can see for yourself. So we had that D here. So if you do D -1, so you cannot access something by an index in a dictionary, right? Because -1 means your key here. This whatever you pass here is your key. So you can pass 9 because 9 was your key. So you can do that. If you had some key like D -1, in that case you could have done. So D -1, let me define it as something like now you have something called D -1 here. Before that you did not have. So now you have -1. So you can do D -1. There's no problem. You'll get heap. So it does not work like an array. So in dictionaries, it's not 1 by 1. So there's no index here. These are not indexes. These are keys. And it's an unordered dictionary. So you cannot do something like D -1. There's nothing like that. Unless and until you have a key with -1. So in that case, you can do D -2 as well and all those things. So anything more? Okay. So in lambda operator is usually like lambda x, then you are doing some kind of thing. But in case of dictionaries, for default dictionary, you are initializing using this. For default dictionaries, if you are doing int, then the default value of int, you'll get the default value of int as your default value in the dictionary, that is 0. For list, you'll get the default value as this. But if you want something else other than that, you'll have to do lambda 7. So for anything, for any key that you pass that is not there, is going to give you 7. It's already 8. We started at 6. I was going to show you this example actually, but we kind of do not have time. I'll just give you this question and you can try it on your own. It's a kickstart question. Kickstart, the one that was held in February. So it was a practice round. You can append and DQ. Okay, sure. So if you're interested, you can try this question out. It's not that difficult. You'll need heap. So that's a hint. You will need heap for this question. I was going to show you this, but there's since there's no time. But append and DQ. So in DQ, append left, pop left, all of these work in O of 1. So it's the same thing as list, as in list. Like there's no difference in DQ and append in DQ and append in a list. all of these are working in O of 1. So if you have a DQ, so I have already imported DQ here, somewhere here. So suppose I have, let's have a DQ here. Let's have an array first and then DQ it. 2, 6, 7, 5, 3. And we are DQing it. Now you have this as DQ. And if you want to append, previously what would have you done? You would have just done dot append and it would have got appended at the end of it. So if you do 9, it gets appended at the end. There's no difference with the list. Like it's the same thing. Whatever the append function in list was doing, it's doing the same thing. For pop, it's doing the exact same thing. So 9 is going to get popped out at the end. So whatever is at the left, whatever is at the right. So that's the default function, pop and append in case of a list. And for removing the leftmost, in case of an array, what would you have done was dot pop then bracket 0. So that thing is going to take O of n time complexity, because the inside function, whatever that is doing, is it's removing, it's placing 6 in place of 2, 7 in place of 6, 5 in place of 7, then 3 in place of 5, and that's how it's removing the 2 from there, right? So that you are shifting each and every element in the array by one place left. So that's taking O of n. So if it was an array and you would have done something like b dot pop 0, so that's what it would have done. But here in case of DQ, what you are doing is the one that I showed you, like head and tail. So in that case, you just need to move your head to one place, right? Move your head to one place, right? So that's what it's doing, and that's only taking you O of 1. So if you do b pop pop left, you are going to get 2 here. Okay? And if you want to append at the left side, you can do append left. Let's append 11. You can see I removed 2 first and then I appended 11. So that's how it's becoming. Okay. So I guess there are no more questions. Okay, then maybe we can end the session here. So if you do not have any question, then we can end the session, or you can ask me if you have any question. And you can check this question out. It's related to heap. You can think something. Binary tree, heap queue. Okay, so I think our next session was going to be on greedy and 2 pointers. Okay. Also, there's going to be a session tomorrow. Our seniors are going to take your session on that. There were some assignments given to you, I believe. So there will be a doubt clearing session tomorrow. And we'll see if we can take a session on implementation of binary tree and heap queue and all. But as for now, the next session that is scheduled for next week is on greedy and 2 pointers. So, okay then. If you do not have any query, then maybe we can end the session. Thank you for joining.